Hey, party people. People who love to party. It's me, Mr. Bill, here to talk to you today about how to use the trig ratios we were working on before and what exactly we can do with them. Specifically, today we're going to be working on how you can use trig ratios to find missing sides. So, if you do not already have this printed out, print it out. If you're like, Mr. Bill, I don't have a printer, take out a separate piece of paper, draw this triangle up. Remember, feel free to pause. It's a video, but do not feel free to just watch the video. Work along with the video. It's how you get better. We need as much practice as we can get. That's how you do math. You can't just watch and know it. All right, so how do we find these missing sides using trig ratios? Because really the only thing we've been working with before was the Pythagorean theorem to find missing sides. And we can still use the Pythagorean theorem. We don't have to throw that away. But as you can see in this, we have a side and an angle. We don't have any of those other sides. We just had one more side. We could use that Pythagorean theorem. Well, this is what trig ratios help us with because they relate angles to sides. So in this case, I would probably pick, I'm going to go from A, even though I could go from C. I don't know if you guys know this, but all the angles in a triangle add together to make 180 degrees. So if I take this 90 and this 42 and minus them from 180, that'll give me how big this angle is. And I could go from C instead. But since I've been given A, and I'm not interested in doing extra work, let's go ahead and go from A. So we're going to take the sine of angle A, and that angle is 42 degrees large. So I would say sine of 42. And for sine, just like we learned the other time, sine is opposite over hypotenuse, or so. That's a mnemonic device so that you can remember it. My opposite side from A, zoo, 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 ding, is 7. My hypotenuse, I don't know, and I'm not sure why I made that 7 so large. So I'm going to turn this into x. It could also be h. It could be any letter you want. 7 over x. That looks pretty bad. Way to go, me. Now I'm going to solve this out. And the way that I like to solve these is by turning them into a proportion. So you put this over 1, because anything can be put over 1, and you would cross multiply that ratio, just in case you haven't done that before. So 1 times 7 makes 7. X times sine of 42 is x times the sine of 42. Like, there's no way around that part. We're still trying to solve for x. I have x times this stuff right here. I'm going to get rid of it by dividing both sides. And I know what you're thinking. This is super weird. I'm dividing by this alphabet thingy in a number. Guys, that is just a number. We can go to our calculator and find that number. That number is approximately, let's see, this would be 7 over, approximately 7 over 0.669. If you're more comfortable finding it and then writing it as that approximated decimal, go for it. The only rules here are, and this will be the rule all the time, in work, 3 decimal places. Or leave in calculator. We got that? To 3 decimal places, or just leave it in the calculator. For our answers, in answers. And this will make sure that we get the same thing every time. So I'm not marking you down for stuff when you actually got it right, because we have the same procedure. But in answers, 1 decimal place. Only 1 number behind the decimal. Okay, let's continue. We then go to our calculator, we go beep, boop, boop, boop. And this is approximately 10.5. Notice how I'm following my conventions. In my work, I had 3 places. In my answer, I only have 1. And that means this guy right here is 10.5. Ta-da, we found that missing side. Now we could use the Pythagorean theorem if we wanted. Or we could continue using trig. I'll do both in this one case. I'm not going to do it over and over again because that's going to make me mad. I want this last side. I could also use tangent. And the reason why I would use tangent of 42 instead of, say, cosine of 42. Cosine of 42 would use this side and the side we just found. I just rounded to get that. I know that this side is not going to be as accurate as that one right there. So I'm trying to use the most accurate information all the time. Tangent of 42 would be, let's see, tangent is opposite over adjacent, or TOA. So I'm going with 7 over, and then we need another letter for this. I'm going to make it y. Why not? And look, I didn't make the 7 super large this time. Way to go me. We're going to put it over 1. We're going to cross multiply. We've got y times the tangent of 42 is equal to 7. Now there's that 7 again. Then we're going to divide by tangent of 42. In this case, if you guys wanted the little numbers there, it looks like I did not put the little numbers for this work piece. So you could change this to the 3 decimal approximation. Let me see what it is real quick. Tangent 42, so 0.900. But instead I just did the division, and I did it ahead of time because I was trying to speed myself up. 7.8 should be how big this side is, 7.8. Now our other option is the Pythagorean theorem. And that would go 7 squared plus y squared is equal to 10.5 squared, which would be 49 plus y squared is equal to 110.25. You'd minus the 49 from both sides. Y squared is going to end up being 61.25. And then you would square root both sides. If you got to rewind that, you can, because it didn't start off as a square root. Whoops, let me move that over. I'm sorry about that. Yikes. I was squaring this thing. That's how that became this. I square rooted it. Y is approximately equal to, let me check that calculator, it's still 7.8. Because of our conventions up here. Right here means that if we follow this, regardless of which way we do it, our answers should be the same the vast majority of the time, despite the fact that we're rounding and we're using different processes. More than one way to do stuff. You want to see more, right? That was too fast. You want more? You could always rewind it. But here, I'll show you this next one too. There we go. Here's our situation, our triangle situation. Move over, computer. There we go. So what trig ratio should we use? If we're going to go from P, and we don't have to, we could go down here from R if we wanted to. If we're going to go from P, it looks like I have my adjacent side, and I could either go looking for my opposite or my hypotenuse. I'm going to go with hypotenuse, which would be cosine. Cosine of 15, and remember cosine is adjacent over hypotenuse, or ka. I don't know if you guys have ever heard before SOHCAHTOA, but it just refers to sine, cosine, and tangent in the way that you use it. The reason why I didn't use tangent, I don't actually like tangent. I'm allowed to not like stuff. I don't know what to tell you. This will be 16 over, I'm going to call this C. I mean, this would be the C side if we're using the Pythagorean theorem. And then I will cross multiply. Put this over 1. 16 times 1 makes 16. Easy stuff. C times cosine of 15 is C times the cosine of 15. Weird stuff. You could turn that into a decimal right now if you wanted to. I'm going to leave it the way that it is, because if I really want to, I could do that at the end. As a matter of fact, I could punch this in my calculator at the end if I wanted to. 6 divided by cosine 15, close the parentheses, bam, answer. But for you, because I'm so kind and handsome, 966, there is the decimal approximation, and C is going to be about 16.6. That's not a lot bigger than this side right here. And that's probably because this side is so small. So I'm going to use the Pythagorean theorem on this one, so I can do it relatively quickly. Let's see, 16 squared plus b squared is equal to 16.6 squared. Let's see, does that show up? Yeah, staying inside the lines this time. 256 plus b squared is equal to 275.56 minus 256 minus 256. I've got b squared is equal to 19.56. And if I square both those sides here, I'll actually write it in 2 steps, even though I don't know about you, but I'd rather just square root that step. Just trying to make it clear for y'all. B is approximately 4.4. Here we go. Ta-da! We did it. Also, this was B. I guess I should write that B there. There you go. So there's one more at the bottom. And if I were you, I would want to try it on my own. We've already got a couple examples. I'm going to see if I can beat Mr. Beal. He's a chump. Doesn't know what he's doing. I got this. You can try it. If you're going to try it, pause it. Because I'm just going to go full steam ahead, get this done. Because on the back, you need to do all that stuff. I'm just going to show you the answers. See, I want this to be G and H. I'm going to set them up ahead of time. And I'm going to use, so that you can see it one more time because I hate it so much and I'm going to try to avoid using it in the future, we're going to use tangent. And remember, tangent was TOA. The tangent is the opposite over the adjacent. So tangent 63 is equal to, let's see, opposite over adjacent. So G over 9. Let me see, did I do that in the other one? Opposite over adjacent. Yeah, I did. I'm good. Wow, my G's and my 9s are a little bit similar, aren't they? Having regrets. Put this over 1, cross multiply. I've got 9 times tangent 63 is equal to G. Wait a second. I don't have to divide this time. Oh, nice. I can just put this in my calculator straight up. 9 times tangent of 63 is, well, really it'd be 9 times 1.963. Did you see how I faked you out, how it looked like I was looking at a calculator, and now I'm looking over here at this page that I've actually already written on? I'm sorry to deceive you briefly, but I was honest in the end. So G is going to be 17.7. If you got that on your own, I'm very proud of you. Otherwise, I'm going to use trig because I could just use trig twice. Remember, I could use a Pythagorean theorem or I could choose to use trig. I'm going to use trig and I'm going to go cosine of 63 is equal to 9. Oh, wait, no. Adjacent. Yeah, 9 over h. Put this over 1, cross multiply. I've got h times the cosine of 63 is equal to 9. This time I do have to divide. I wonder how it could be so that I don't have to divide. Not dividing that time was amazing and wonderful. Let's see, so this is approximately 9 over 0.454. Ooh, that's getting rough, sorry. Which is approximately, ooh, I hope this fits in, 19.8. Oh my God. 19.8. It's 19.8. About. We did do some rounding. There you go, guys. That is the whole front. I now want you to try the back. Now that might have been quick. It's okay to go back and look. What I want to assure you before you do the back as well, you see this time right here where we actually got to multiply and we didn't have to divide. That is not true for just tangent. That can happen for cosine and sine as well. If you already have the hypotenuse, but you're missing the one that goes on top, you don't have to divide. Super nice. So don't get stuck and think that every time you're going to have to divide. Sometimes it's multiply, sometimes it's divide. Okay. All right. Hey, flip on over just in case you do not print these things out. You're going to have to look at these and write them down real quick because I can't leave them up here for too long because this video is getting too long. And yes, the numbering's crazy because I stole these from another thing. Moving on up. I know what you're thinking. This is too fast, Mr. Beal. Stop. Stop so that I can write them down. No, pause it. So you pause it at any time. All these times you could be pausing. You tripping right now. I wish you had a printer. I bet you wish you had a printer too. I'm not trying to rub that in. I'm sorry. And there's the last ones. Ooh, look at those. All right, guys, I'm going to pause it so that you can do them. And we will come back and we will check them. Although it'll just be like a second. It'll be like a second. We're back. There's the second. And there's that work. Ooh, look at all that good work. Just going to go through some highlights. I wasn't doing my division step because I didn't have a lot of space. But you can see I definitely needed to divide in this one, for sure. This one was a times. So nice. This one ended up being a divide. Poop. There are the answers right below so that you can see them. This one was a times, very nice, 6.9. This one a divide, 39.7. This one a times, 15.6. And remember, it's okay to pause. This button still exists. Let's see, this was a times, 6.4, times 5.2, times. This one was so nice, so much. Wait, am I crazy? No, this was all times. You guys should be thanking me for assigning that. And then the tough ones. These were all real tough, and I'm going to zoom in a bit so that you can see what was going on, because I asked you to find all the sides, not just one side limited. So I went with this side first. I used sine. You could have used a different trig ratio and found a different side first, but we should still have the same answers. At least they should be really, 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 really close to each other. Really, really. There's all my work. 9.5, 12.4. I used tangent to start with, something I won't do often. And then I used sine. I didn't even use the Pythagorean theorem on this one. And then over here, I got to use my old friend, my favorite, sine. And then I used the Pythagorean theorem, even though the dude was a cult leader and was crazy. All right, party people. That's it for today. I'll be coming at you next with, I don't know, probably finding angles. That would be my guess. All right. Hey, world's crazy. Stay safe.